The last bit of this chapter is on human feedback. So obviously we are driving climate change to a large extent with our greenhouse gas emissions, land use change, and so on. But we are also reacting to this climate change and in many cases exacerbating the climate change we have caused. Feels like a lot of noise here, but I hope it's very clear. Let's look at some examples. Okay, so the meteorological measure of climate change here could be higher overall temperatures and other things like milder spring and autumn, milder winter climates. The impact on human well-beings are things like thermal discomfort in buildings. So the human response is to increase the use of air conditioning. And air conditioners are argued to be one of the worst for climate change. And there is now a global cooling challenge which provides money for increasing the efficiency of air conditioners. We are not only using HFCs largely and producing a lot of tremendously harmful greenhouse gases in terms of HFCs, but also the efficiency of those things is really pathetic. So obviously leads to high energy consumption and raised emissions and positive feedbacks. Obviously, air conditioning is a direct adaptation to climate change, but there are more horrible issues. So this is, for example, the Indian situation where as the income goes up and temperatures keep warming in the tropics, people are beginning to rely more and more on window units for ACs, which are freely emitting into the atmosphere, which is already very hot. But obviously you cannot tell people not to use air conditioners, so efficiency has to go up, plus the HFC replacements have to come in pretty soon. So countries like India are given extra time to replace HFCs under the Paris Agreement, but obviously there is no choice. But the second part that is more convoluted is that drier climate in coastal regions is actually increasing water shortage, which means what? People think, well, there is so much ocean water, we can just desalinate it. But these are very, very energy intensive as of now, even though there are some attempts to use solar energy for doing this. But then transporting it away from the coasts into the interior will be another challenge that has to be met. Already, bottled water business is big, and people sell the Alps water, Evian, the Himalayan water, and the fancy water from the Andes glaciers, and so on and so forth. But they all include high energy consumption, again leading to emissions increase and exacerbating the global warming. On the other hand, milder springs and autumns associated with global warming at higher latitudes are giving extended period of thermal comfort in peripheral domestic areas like conservatory extensions to houses and the technology of double glazing of the windows. Conservatories are either used like greenhouse gases for gardening and so on, or they are just lounges attached to the house itself with nice beautiful glass walls and ceilings, and they are made storm windows, loss of energy is reduced, and so on. But the unintended consequence, of course, is that space heaters, which are very inefficient energy guzzling heaters for these outside spaces, have also increased. Okay, so space heating is added to conservatories to make them usable even during the winter times when they are really cold, too cold to be outside. So this glazing of the windows, which actually is meant for reducing energy use, actually has led to increased energy use because of these space heaters being used as a way to extend the stay outside. They're beautiful, they're fun, they're comfortable, and they are obviously soothing and so on, but they involve high energy consumption again, and emissions increase, and increased warming. Okay, milder winter climates, improved thermal comfort in buildings, so there is reduced use of fossil fuel heating and firewood in these cases, so reduced energy consumption, and of course related deforestation. This leads to lowered emissions and negative feedback, so there is a little bit of a positive good news there. But one should remember that in general, when efficiencies go up, there is something called Jevons paradox, which says that it's wholly a confusion to suppose that more efficient lighting leads to diminished consumption. The very contrary is the truth. This has been found even for people who buy hybrid cars, for example. It's called a one-action bias in some cases, where you buy a hybrid car, you think you are doing good for the atmosphere, for the global warming, so the number of miles you drive begins to inch up a little because you think you are not doing as much harm. Plus, there is good work by Gidon Eshel and colleagues showing that even if you're driving a hybrid, if you're consuming a lot of meat, your carbon footprint can be higher than somebody who's driving an SUV, which is not as fuel efficient as the hybrid. But if the person is a vegetarian, then their carbon footprint can be actually lower than a hybrid person with lots of meat consumption. So there is always this multiple portfolio members of carbon footprint in your daily life, traveling, commuting, energy use for various things without solar photovoltaics or solar thermal, and so on and so forth. So the human feedbacks again are very complicated, but models are beginning to include lifestyle consumptions and other things as part of the Earth system feedback. And in fact, with need for multi-year predictions and decadal predictions to long-term projections, these feedbacks become very critical, especially if population doesn't come down. So that's another whole can of worms, that whether population is really going to go up to 10 billion, or is it going to start coming down because educated women want to have fewer and fewer kids. But fewer kids also come with increased consumption, so it's not just population, it's the consumption that also becomes part of the story when you talk about population. So the human feedbacks are also quite complicated. So that's the summary of this chapter. Kind of long, but I run through all the important feedbacks and some idea on how models are doing it and how much of it they are doing, how they try to validate it, and how they are used in projections and so on. So we will move on to the details of these relevant feedbacks into adaptation and mitigation and so on as we go deeper into the course. Okay.